I'm Bill Bupert, retired Army officer and irregular warfare practitioner and scholar. Welcome to Chasing Ghosts, an Irregular Warfare podcast, the show that examines the mythos, lost history, bad thinking, martial malpractice, and government incompetence that informs so much of irregular warfare. I want to peek behind the curtain at the vast machinery and briar patch politics of insurgency and counterinsurgency, and everything in between. Now, let's go ghost hunting together. Hello, this is Bill, and welcome to episode 44 of Chasing Ghost, an Irregular Warfare podcast. The title of this episode is CG Excursion Praxis, Rational Concepts of Operations, CONOPS. So, I'm going to be taking yet another bit of a departure, as I have in the past with explaining how conventional warfare works, as opposed to unconventional warfare, and some of the series that I've both spoken to in my podcasts and written about in my dispatch essays concerning carriers. And this one is, I grow tired and weary of people not thinking things through, not extrapolating second and third order effects, not anticipating unintended consequences, not being able to wrap their heads around what should be pretty obvious to people who try to play these kind of things in a game of anticipatory chess, in which you don't become a pinball, but you become a more solid and purposeful agent in your life and at higher levels, strategic, operational, maybe even grand strategic levels. This kind of preamble to action may make things more rational and have better outcomes. A little bit of housekeeping. I post notes at my Substack, and those are my brain zephyrs that I come up with. Sometimes I'll be on Twitter, sometimes I won't. Sometimes I'll be on Gab, sometimes I won't. I find that Gab and Twitter, as much as I like them as social media entities that can expand the audience that I have here for this podcast, and maybe even a great stage to share my thoughts, I find they're time vampires. So I use the notes function of my Substack, which you can visit, as a way to sort of talk about things that may not be of great importance, but they're observations that I want to make stick. At the Libertarian Institute, where I am the Smedley D. Butler Fellow for Military Affairs, they have a blog, and I try to post practically on a daily basis about the Keystone Cops, Three Stooges, continuing comedy of American and Western military affairs. So if you hop over to the Libertarian Institute, check out the blog, you'll see some of my posts. I have some amusing and depressing posts about the state of the war machine in the West. The word praxis comes from the School of Austrian Economics, but it's also used in larger academia as a means to provide a summary, a précis, an abstract of what you're trying to get across. So I'm hoping in the next hour or so, where I talk about concepts of operations, concepts of employment, and functional descriptions, this can be rather technical, and I will provide in the show notes places you can go to get a much deeper and broader appreciation of the application of this, not only in your professional, but in your personal life. As many of you know, as a result of listening to this podcast, or maybe you've read stuff that I've written years before on various venues that I have written on or I've been interviewed on, I'm always concerned about thinking, not necessarily correct thinking, but good thinking, deep thinking, critical thinking. My definition, of course, of critical thinking is very simple, and this is something you can broadcast to everybody far and wide and see if it makes an impact. Critical thinking is about thinking about your thinking to improve your thinking through better thinking. Now, that seems flippant. It seems almost comedic. It's not. The reason people don't like to think critically has several permutations. Number one, it takes work. Number two, it forces you to look uncomfortably into the abyss of your knowledge deficits. Number 3, it makes you reappraise solid conceptual frameworks that you've embraced your entire life, but all of a sudden you run against an epistemological brick wall in which all of those notions you had evaporate before your very eyes because they don't hold philosophical, moral, or intellectual or epistemological water anymore. And you've got to face that down. Again, this seems arcane and esoteric, but remember, these brain cases that we have above our necks are designed for instantiating pattern relationships, critically looking at the world around us, trying to apprehend what that world means from the moral, philosophical, and intellectual level, trying to constantly, I would say, if you're active about it, reappraise who you are, what parts you play in the world, what parts you play with friends, families, acquaintances. If you're a public speaker, what kind of mission sets or what kind of things are you trying to achieve by talking to people, much as I do with my podcast here, speaking of arcane and esoteric, because I'm never going to be as popular as Joe Rogan, don't have his charisma. I'm never going to be as popular as a lot of those people who have literally hundreds of thousands of listeners and subscribers for their podcast, because I just so happen to have a podcast that's devoted to a very exotic subject that also has to a certain extent, provenance and interest that not a lot of people can even develop a hunger or yearning to learn more about. So for those of you only interested in hearing about my commentary about irregular warfare, you may want to skip this episode, because what I'm going to talk to you about is the nuts and bolts. In this case, I think this could be one of several episodes. The nuts and bolts of critical thinking. In this case, I'm going to talk about something that is rather exotic, that's used in the military, that's used around the world in manufacturing concerns that want to make sure that at the beginning, when they plan on opening the doors to a facility or improving on legacy products or coming up with blue sky products or services and these kind of things, at what in the military we would call the concepts and requirements stage, which is instantiating the baseline for what you seek to do with the intent that you've been given. How are you going to approach that so that you inventory and think through everything with pen, paper, computer, whiteboards, whatever the case may be, before a single tool is turned, before a single warehouse is purchased, to make sure that that intent given to you by the money people, your corporate CEO, the flag officers, the field grade officers, whatever it may be in this enterprise that you're about to embark on, if you're providing a good and service, and of course we have the Pentagon, which does that, and they do it in a very poor and shoddy fashion consistently. Again, Libertarian Institute, my blog pieces, I give you sorry anecdote after sorry anecdote and example of how that's occurring now and has been occurring for decades. So in my career as what John Cleese would deem a Renaissance man, I have been, and am presently, a systems engineer. More appropriately, a system of systems engineer. I'm fond, when I'm training young engineers and have the occasion to do so, of asking my audience about their engineering pedigrees. What are their engineering provenance? Are you mechanical? Are you aerospace? Are you chemical? Are you industrial? Whatever the case may be. And then I say, raise your hand if you're a systems engineer. And I'll get 2 people, 3 people among 24 who raise their hands. And then I'll ask the follow-on question I just asked, what mechanical, aerospace, whatever the case may be. Then after that, I will correct everybody in the room and say that everybody in this room who is an engineer is a systems engineer by trade, training, and predisposition, because if you're not, you can't turn science into a manifestation of real-world working objects and services. This is about thinking about planning. This is about anticipating whatever intent in 1, 2 sentences, 1 paragraph of what you seek to accomplish at the end of this small or large enterprise. What does it look like? How do we tackle the who, when, where, why, and how? How do we get ourselves in a position for success where we won't have to spend an inordinate amount of money due to piss poor planning at the beginning. NASA, and of course I will put this in the show notes, NASA came up with a very interesting study where they found that at the concepts and requirements baseline in systems engineering, if you don't find a way to do that in a rational and comprehensive manner, and you have to make course changes midstream, you have to make important deviations from what the plan was in the first place, it can cost you up to 1,500 times as much as you initially planned on spending. And of course, if one takes a look at all of the prestige and elite programs in the Navy, the Air Force, the Army, from the failures to the successes, you will find these stories in a small way. You will find these stories in a large way. Stories in a large way such as the little crappy ships with the U.S. Navy, which suffered directly from having immature, insufficient, and very badly crafted concepts of operations. And then you'll find aircraft doing the same thing. You'll find tracked and wheeled vehicles doing the very same thing. So the defense industry in the U.S. and the West provides a very rich and deep encyclopedia-like resource to find out not only how not to do things, but on occasion, how to do them correctly. So let me acquaint you with levels of concepts of operations. Now, concepts of operations, of course, would be what is it we're trying to achieve, and working backwards, doing reverse planning, how do we get to that point of what we're trying to achieve? Whether we're building a ballpoint pen, we're building a commercial airliner, we're building a military aircraft, or we're building a carrier. What is it that we want that to achieve? That must be informed at the baseline level, at concepts and requirements, in order to rationally, and by the way, economically and within price constraints that one is extrapolating, get there in a purposeful, reasonable, and rational fashion. So the levels of CONOPS are, we have overviews, and that's the who or what pieces are involved. We have advocacy, why the change is needed. We have architectural, how the parts interrelate. We have operational, when the pieces should work together. And we have design, where in detail the pieces fit together in the design. Of course, when that happens, especially when one is in sophisticated and complex manufacturing processes, we have two paths forward in doing that. There are some things that have to be built in parallel, which means that they can be built independent of each other. And there are other things that have to be built in series or serial, which means that one thing must be complete before you can move on to the next thing. So what is a CONOPS? CONOPS it's the operation version of a business plan, which some of you may be acquainted with. It's all about what are we trying to do? What's our intent? Why are we doing this? For whom are we doing this? When will this be used? And who will it be used by? Where? What's the purpose? Under what conditions? How often will it be used? How will it be maintained? And who will maintain it? And what does that look like as far as the maintenance, both personnel and the assets needed? And can that happen, in the case of the military, in an austere environment? How will we make this happen, and who and what else will be impacted, and how? Now, I've given you sort of like a thumbnail sketch of some of those things that we'd have to consider. I'm certain that other listeners out there within your various niche industries that you may be in will have other concerns or lesser concerns than what I just outlined. And before I go on, of course, I've got to tell you, why bother? Well, building CONOPS shapes the procurement. In this case, procurement is usually a four-letter word, a dirty word that's used in the government, but all corporations use that, of course, too. CONOPS are being required everywhere throughout the government community, and I would say that if any of you in this audience happen to work in the private sector, you will find CONOPS a very useful way to drive systems engineering processes. And even if you're making potato chips, even if you're building car parts, even if you're constructing firearms, everything that you construct for the most part, and I alluded to a pen earlier, or even a pencil, these are systems of systems. These are things that you have to wrap your head around to make sure that not only building the product or service itself, how are you going to deliver it? Are you going to have to provide field service representatives or assets out there to support it once it hits the ground, once people have purchased it, once it finds itself in a combat zone, once it's sitting for 10, 15, 20, 25 years in either a CONOPS or a weapon system that isn't used until, by the way, it's used. It also uncovers hidden assumptions, which saves you money later, of course. And it provides a living blueprint for any project that you have. Now, having a sound CONOPS just makes good common sense for any project. Heads off interoperability problems before they arise, interoperability being, of course, these systems of systems working with each other and maybe even working with systems they may not have initially been designed for but could be modified or adapted to work with afterwards. Remember, a lot of genius comes from interdisciplinary ferment. One day a chemical engineer and electrical engineer had lunch, and hence the automotive battery comes into being. You get teams working towards common vision, and it helps executives quickly see and support operational benefits. Now, what I find with a lot of this, and I've drawn a lot of this wisdom from a company that I think has gone out of business, unfortunately, called Solid Thinking. And these guys did great work on training CONOPS folks and CONOPS folks, both military and otherwise, I think going back decades, but I look for them. Apparently they've disappeared. That's too bad. And this also documents users' needs and establishes top-level requirements. And by the way, here's a cool thing that I think about this. And we all draw from our diverse backgrounds, as it were. As I've alluded to earlier, Special Forces has a very interesting back brief and brief back concept of operations that they employ. A given A-team, an A detachment of 8 to 12 men in a Special Forces battalion is given a mission by the battalion commander. Then they're given approximately 48 to 72 hours to go into ISOFAC, the isolation facility, and they take the commander's intent and they work through all the CONOPS and CONEMS, concepts of employment, and they take it down to a very granular and atomistic level, and then at the conclusion of that 48 to 72 hours, the commander, the battalion commander, returns to get a briefing from the team where they tell him what their mission is, as understood by them, and all the parts and pieces and all the granular aspects they took to make it happen and make sure that it could happen. They brief that to the commander, and he gives a yay or nay on two things. Number one, their interpretation of his order is correct to see to the intent that he put out there. And number two, maybe they've got improvements. As a matter of fact, it can get so radically atomistic and so extrapolative in trying to find out the best way to achieve the mission, that the intent that this battalion commander have, that it may even be a reason to abort it as a result of them showing the impossibility or improbability of success with what the commander wanted in the first place. Now, that's isolated to SF. I've written in notes before. By the way, I will also provide a link in the show notes for this very document. For those of you too excited to wait for the show notes, that's the Special Forces Detachment Mission Planning Guide, January 2020. It is GTA 31-01-003. And man, I think this is probably one of the best military documents ever issued for planning purposes in the history of the U.S. Armed Forces. So I would urge you to get a copy. I think that you can get while Amazon will sell it to you, I think that you can get a PDF copy online. Here's the bottom line. Without solid concept analysis, OpCons and CONOPS, which would be operational concepts versus concepts of operations. I'm not going to bore you with the distinction there because it doesn't matter. Things often go terribly wrong. And I happen to think that in large part, that is a reason why there are so many failed weapon systems in America, and in the West more so in America, is because they did not do their homework to the extent that they needed to. They got captured by groupthink, and they refused to acknowledge that the initial assignations that they assigned to what they were trying to get done may have been incorrect, but they didn't have the moral courage to make that happen. Now, poor CONOPS cause errors in requirements specification. I know this seems a bit esoteric and even technical. It is. There's no doubt about it. But as I mentioned earlier, you can take everything that I'm going to talk to you about today. You can use it in your professional life, no matter what you do for a living. You can use this in your personal life, no matter what you do for a living. And you will find that this is a means by which you can create a better place for you and your family and your friends and your colleagues. Costs skyrocket, as I mentioned, with that NASA study during development. And these errors in the requirement specification, they cost big money. I've talked about, it could cost 1,500 times, but there are cases for finding and fixing at design stages that I've been on where it was 5 times as much. When it comes to software coding, it could be 10 times as much. When it comes to insufficient testing and testing requirements at every stage in development, operations, manufacturing, and final living in the wild of these goods and services, 20 times or more at testing, 200 times when it comes to delivery. This is why recalls are so awful for automotive companies, because if they had done proper CONOPS, in my estimation, they could have avoided a lot of that unneeded expense. I like Government Accountability Office and Congressional Research Service documents because they tend to do a really good job with footnotes, a really good job dispassionately taking a look at really wicked problem sets. They may not always come up with solutions, but they're really good at laying out what were the root causes and proximate causes that caused, one of Bill's favorite phrases, of course, is chaos avalanches. So that's what I'll call it. What caused these chaos avalanches where costs skyrocketed or the thing just didn't work? In engineering lingo, a root cause is the root cause once you've done your failure analysis of where the buck stops right there. But proximate causes is everything that ripples out from that root causes over a system or ecology of problems that occur in wicked problem sets. So I'll bet some of you, and I would love for my audience members to send me a more updated one, but this particular GAO report is from 2004, and it's titled, Stronger Management Practices Are Needed to Improve DoD Software-Intensive Weapons Acquisition. By gosh, this is 2004, 2 decades ago, but all of this resonates today at this very minute with the way the acquisition system and platform failures are occurring across the board in the U.S. military. Quote, a 1999 study performed by the Standish Group, an organization that researches risk, cost, and investment return for information technology improvements, found that about 1/3 of software development programs, commercial or military, resulted in cancellation. Furthermore, in a series of studies completed through the 1990s, the group found that the average cost overrun was 189%, the average schedule overrun was 222% of the original estimate, and on average, only 61% of the projects were delivered with originally specified features or functions. Developers at the better firms pay particular attention to the requirements setting process because requirements are the foundation of a development effort. If requirements are not well defined, or if there are too many changes, the result is additional, sometimes unmanageable risk. End of quote. It's a mouthful, but it really instantiates in real world terms exactly what the cost of not doing rational and prescriptive concepts of operations at the very, very beginning of any large enterprise you take part in, small enterprises included. You do this at your own peril. So you want to build teams. As a matter of fact, I think everybody should be at least acquainted in baseline with what CONOPS are about. And you can have people who have the interest or disposition to do this more deeply and frequently. Well, hire them up in your organization. Building CONOPS are requirements that capture purpose, functionality, and utility of a system. That's what they do in essence. It works to eliminate latent defects. It builds systems that meet users' evolving needs. On schedule and on budget, of course, on schedule and on budget is a pipe dream for the U.S. military. It prevents the development of any system that meets specs and individual functional requirements, but as a whole, it fails to meet the user's needs. Again, why do we do this? Well, because we build things, we buy things, we make sure that groups are working together and they have a common intent in mind on what they're trying to achieve. It explains things in a much deeper and thorough and rational fashion so that everybody is on the same page about what that intent is that is trying to be achieved. There's a typical progression in all of this. You have to establish an operational need, from whence one gets an operating concept, from whence one develops the concept of operations, and that informs what the operational requirement is in the end, so that you have baselined and templated directly to the intent given for what you're trying to achieve, so that you could do it in a rational, effective, and hopefully price-conscious means. That operational need, that's the attributes. That's the initial brainstorming. Now, this can be informal, however you wish to do it. It can be formalized, or it can be, as we discovered in Afghanistan and other places around the world, it can happen during operations. Operating concept, common uses are you're determining the operational utility of an idea. Does it have a purpose? There's something that we did in the military, which is what is the military use of what we're trying to do? How do we weaponize this? And what effects can it have at the tactical, operational, and strategic level? And by the way, I'd mentioned CONOPS, concepts of employment, earlier. They are not CONOPS. And I also consider CONOPS to be a subset under the umbrella rubric of CONOPS. What the concept of employment does for you is it describes how the component or device will be used. It's an emphasis on things, not people. An example could be the braking system for a car, the doors on an airliner, or it could be a rifle or a mortar, whatever the case may be. There's also something called operating concept. What this does as a preamble to the CONOPS itself is it determines the operational utility of an idea. As a matter of fact, it can give you a red light or a green light on whether you should continue or not. You reach a consensus on that concept, on that approach, who's going to be participating in this, and it prepares you to give a more rational CONOPS. It also shows the basic components, the relationships, the dependencies, and it drives out top-level requirements by instantiating what they are and taking them out of the wild and tackling them to the ground and putting it up there on the whiteboard so that everybody can recognize what it is. Which brings me to a very interesting document that I've used in my uniformed professional life and now I use in my engineering life. And that would be a very curious mill standard publication. Again, I will provide a link to this document. I urge you not to download the entire, download it, but don't print out the whole thing. Print out whatever is what you need to do. It's called the Department of Defense Standard Practice Work Breakdown Structures for Defense Material Items. It is Mill Standard 881 Echo. I do think an 881 Foxtrot may be out there as we speak, which is a revision to the standard for this. This large, imposing document of 250 pages should not challenge you or frighten you to a point because it's so big. Because, for instance, in my profession, there's essentially 5 pages out of this entire thing that I use as a decomposition grid and map to do what I have to do. So in this case, what it is, it's a product-based breakdown structure and a work breakdown structure. And to make it super simple for the audience, for those of you unfamiliar, because I'm certain that some of my listeners are intimately familiar with Mill Standard 881. But for those who aren't familiar with it, let me break it down to a very simple way to know what this is. A product breakdown structure is this. I want to create a new pen, but I'm going to use a legacy pen as a template. And I'm going to do something that's called decomposition, and I'm going to do something that involves parent and child relationships, and I'm going to take them down to the most atomistic level that I can until I have to stop because I can't break it down any further. Hence the word breakdown in this case. So if you want, while you're listening to this, if you happen to be at home, grab a ballpoint pen and take that puppy apart until you can't take it apart anymore. You have a spring. You have the ink device. You may have 2 plastic parts and pieces. You may have a band there. You may have a button at the top. You take all these constituent parts and pieces down. You could do the same thing to a car. You can do the same thing to a snowboard. You can do the same thing to a rifle or a pistol if you happen to be an amateur gunsmith who builds guns at home. What you discover is you lay this all out in front of you, and that is your product breakdown structure. And what you can do with that product breakdown structure is either sequentially, by breaking it down in a sequence or just taking it apart, you determine what the parent-child relationships are. And in this case, the child relationship, the parent, of course, is the pen. The child relationship is all of those parts and pieces and components that make it whole once they are put back together again. So I've done that. So I've taken it apart. I put it up there on a whiteboard, or maybe I've got a planner who's very talented on a computer, and he can get illustrations of these parts and pieces, and we put on a nice either computer tablet or on a whiteboard, whatever the case may be. Now we go to work breakdown structure, which is, and we can't do that before we do the product breakdown structure, because otherwise, if you do the PBS afterwards, how in the heck would you know what you're going to work to build in the first place? What the work breakdown structure does is by hours, components, supply chains, all of those things, you determine, again through decomposition, again through parents and children, again through who's going to build the plastic devices, who's going to build the metal devices, where are we going to source those from? As far as ink delivery, how is that going to occur and all this? And that determines your work breakdown structure. Thus, by taking the work breakdown structure and the product breakdown structure, marrying those together, there is no other way on earth in this mortal coil to come up with a process map that gets you to manufacturing, operations, and final delivery of your good and service. It's a tedious process, which is why a lot of people don't do it. In my current organization, which is very large, there's very few of us who I consider myself a master of this process, one of the few things I've mastered in my life. There are very few people who are masters of this tedious process, but the return on investment of doing this at the beginning is that it saves you so much hassle because of oversights, delays, mistakes that were a result of not having a rational baseline to begin with. So again, I will leave a copy of 881 Echo or Foxtrot, if they've issued that, in the show notes. You can look at that table of contents. Whatever industry you may be in that produces stuff, you will find a very handy decomposition primer in there on whatever your particular commodity is that you will find very useful if you're trying, number one, to improve legacy products, or number two, it's a blue sky thing. You're building this from scratch. Well, how are you going to do it? This provides you the basis for the most part of how to do that. Again, I want to pause here briefly And what the heck am I going on about here? I mean, Bill does an Irregular Warfare podcast. Why in the world is he talking about critical thinking, talking about mission planning, talking about concepts of operations, talking about WBS and PBS and all of this stuff that seems, to those of you who may not be as interested in it as me, arcane, esoteric, and maybe even immaterial to this? The reason why is I put great import, as you may have noticed, not only on language specificity, but thinking things through where I measure to the best of my ability unintended consequences, and I extrapolate through forecasting or prediction to the best of my ability, trying to get that single most accurate picture by looking at the second and third order effects of whatever it is I do or smaller or larger organizations do in concert with other smaller or larger organizations do, to try to determine, well, what's the best case for moving forward? What's the worst case for moving forward? But if we refuse to be rigorous, thoughtful, and absolutely brutal in red teaming ourselves and entertaining contrarian ideas and trying to make sure that we have worked out all the possible, let's say probable, problems in a given enterprise, well, as I am fond of saying, Newton's third law is a stone-cold motherfucker, and you will suffer. So I'm at a disadvantage here because I'm on a podcast in which I am delivering via a narrative format with no pictures, no video whatsoever, and trying to discover what does turn out to be a rather complex process. But nonetheless, if you guys take a look at my show notes and get some of the documents that I've delineated, you'll find ways to revisit all of this and maybe master the craft, or at least get on with trying to master the craft. In the concepts analysis, you've got precursors to these CONOPS. You're trying to identify all of your user viewpoints, and it forces a triage of needs. It tells you, well, what's essential, what's desirable, what's highly desirable. And further prioritization within these categories, that assists you with incremental development processes, iterative development processes, as I described earlier, which is going to be in parallel or maybe in series. And it also clarifies, and make sure you have the moral courage to do this if you do this in a group. It also clarifies vague desires and opinions. It eliminates misconceptions. And that culminates in the operating concept that you need to lead to the CONOPS that you're going to do in the next thing. Because in OpCon, that operating concept, it's a description, usually graphical, showing the major interactive participants, players, subsystems, and their interrelationships in building this. So again, not trying to be confusing, but this operating concept is vital as a preamble and a precursor to developing rational CONOPS. So we're going to use airports as an example here. That way we're sort of straddling both the military and civilian ecologies. So we want to identify who are the major players, what are the major components. We want to understand the basic relationships, and we want to show dependencies among groups. Now, dependencies in this case would be what I was just delineating about. What are the things that are connected? And also, as I was just talking about with the WBS and the PBS, which is the work breakdown structure and product breakdown structure, dependencies, parent and child relationships, is what's instantiated there. So we're going to assume 5 major participants in airport operations. You've got ATC, the air traffic controllers, pilots, airlines, passengers, and the airport management itself. Now there's 3 primary user groups in airport ground operations. That's pilots, air traffic controllers, airport management. So we're going to go over some responsibilities here, because if you don't delineate and tease out all the responsibilities, then you don't know who is going to be liable to do everything in this complex choreography of trying to come up with these so that we can inform our CONOPS. So pilot responsibilities, for instance, would be they're going to obey all the FAA and the IATA and the ICAO constructs and procedures that they have to in their profession. They move only when cleared. They get ATC confirmation for any request. They repeat all clearances. They assume nothing and verify everything. Hence, the pre-flight checks. That can take a half hour or an hour in commercial airlines. And of course, on-time departures and arrivals. Although I found anecdotally that's not a big priority for any American domestic airline anymore. Now, what are the ATC responsibilities? They also have to follow the IATA and the ICAO procedures. Those are international and commercial organizations for flying. They grant requests whenever possible. They issue clearances in a timely manner, and they assume nothing, verify everything. Again, they assume nothing, verify everything. Airport management responsibilities. They also follow all the professional guidelines. They give a safe, well-lit, and marked airport surface area, and other things. So what are the interdependencies of these? Because I've just described pilots, ATC controllers, and the airport managers. Well, of course, all of those are interdependent on each other in order to make the primary mission work, which is that airline with sufficient passengers goes aloft in a safe fashion, continues its travel, and lands at another airport in a reverse planning scenario where everything is done in the exact opposite sequence for it to land and disembark the passengers. So what you find, though, is that some of these things may break down if you haven't communicated them or discussed them or templated them in a fashion that appears to be rational. In applied engineering, there happens to be a very mature and sophisticated failure analysis routine and system that's used to walk back mistakes, errors, and things that are observed to take into account just what happened so that it doesn't happen again in the future. So I remember reading a book about Elon Musk in the early days of SpaceX, and he recounted a very interesting thing in which in one of the Falcon launches, when there was a separation between the first stage and the second stage, in the software code, they had neglected to time it properly so that the non-energized impulse forward, in other words, the object is going up. There's going to be a separation from both stages. They should have calculated precisely what the non-energized impulse movement forward would be so that first and second stage wouldn't collide with each other, because what happened is the software code was incorrect and they separated from one another without taking that into account, and as a result the first stage bumped the second stage and everything tumbled. It did not go in the correct fashion. All of this, of course, was divined from a very clear and sophisticated failure analysis process that is part of the corporate ecology at SpaceX, in which there's full kimono disclosure on any mistakes that are made. And unlike in the government and unlike in the defense manufacturing community, where finger pointing is done not to find out what the problem is, but to blame somebody else for what may have been an error in the first place on the person pointing the finger. So that's something that has to be done. I mean, I mentioned moral courage earlier, and this is a component of that, where you have to be willing, after a failure has occurred, after you have conducted the failure analysis, to take a determination on what or who is to blame, and not simply to use that as a means to fire them unless they're incompetent, but as a means to ameliorate what caused the problem in the first place, move forward with an improved system, and then you're able to be successful. There's other illustrations of this operating concept that is a preamble to a concept of operations that is rational. For instance, I just took 4 episodes to describe in my Storming America series what an upsized October 7th attack from Gaza to Israel would look like in the United States if the same thing were to occur. Now, when that happens on U.S. soil, it's good to have all of your local, county, state, and federal law enforcement coordinating along with the court systems, maybe the FBI, maybe EMS, maybe emergency management services from the local to the federal level, where they've already done the operating concepts of what it is they're trying to achieve. For instance, when I did a brief stint in the U.S. Forest Service, they have a really interesting thing called incident command. And what it means is that, and my brother-in-law is a senior guy in the fire service in Idaho, so he's expert at this, is that the first guy on the scene, who's middle management, maybe senior minus, who is there, he becomes the incident commander because of the experiential database of being first on the scene, with the knowledge and competence that he has, to include that unconscious competence of being at something for decades. No matter how senior the guy is who comes into that sector at the time, the original incident commander, unless relieved for incompetence, is the guy who calls the shots and calls the ball, because he's the guy with the greatest contextual understanding of what's going on right there, in this case, wildland firefighting. Another example would be, what's an operating concept for building a house? Well, a blueprint would help, wouldn't it? Because then you have a purposeful intent that will guide you through everything that you have to do inside the house that is going to be heated and cooled. Maybe the garage that isn't going to be heated and cooled, but it's certainly going to have entrance parameters that go into the house and such, and the exterior. Now, building a house as a general contractor means that you're going to have a plumber, you're going to have grading and septic, you're going to have roofing and framing, you're going to have an electrician, you're going to have interior finishing. Then you most likely have to deal with your local and county government for all the things that have to be done in train as far as documentation, with the exception I mentioned I've lived in North Idaho, and thankfully their building department was dissolved when I got there, so I didn't have to deal with that nonsense. But nonetheless, most localities, that's going to be part of your operating concept before you can even develop a concept of operations, because all of this informs what that concept of operations is going to look like. Okay, buckle up. I hate to tell you this, but I may have to do some math on air, because I must describe to you and illustrate how complex interrelationships can get, and this happens with more than two nodes. For instance, the number of possible bilateral interactions and relationships equals, in this case, x squared minus x over 2. Now, to explain that in simpler terms, what it means is that I'm trying to get a data link maybe between 2 groups, 4 groups, 6 groups, and when I'm doing that, there's going to be combinations in those groups that expand the number of interactions, in this case, the unilateral data flows. So, in the end, OpCon complexity climbs fast as more players join. This should be pretty intuitive for everybody listening. In an example, an interplay of 6 nodes and groups is 50% more complex than 5 groups, 30 data exchanges versus 20. So imagine graphically portraying even 20 relationships is difficult. Again, my apologies for doing math on air, because I know that that is always suboptimal, but there it is. There's some way where I have to illustrate to you or convince you that the more groups and stakeholders involved in a single operation, those complexities of nodal relationships become worse and worse. Now, there's a systems complexity, but there's also a systems approach to building this OpCon. Again, the preamble, this operational concept, the preamble to the CONOPS themselves. This is a subset thereof. Who or what are the major nodes? What processes and functions does each perform? What input does each need to do its job, and from whom or what? And what output does each provide, and to whom and what? For instance, in a terrorist incident, as I've described in the 4 previous episodes, if the homework was done, all of the communications infrastructure is in place so that there is a seamless capability for not only EMS, not only fire departments, not only the police, not only the intelligence nodes, but even decision makers to be netted in. So before this thing happens, they have an operating concept of how to respond if something like that happens. Now, I would tell you that is not the case in America right now at any level, and we are in the hazard when it comes not having templated these OpCons. What you'll want to do is take constituent parts, pieces, and components of everything, and you could do this. I just described what's going to happen for a response to a terrorist incident. I just described what happens in airports. Whether you run an automotive repair shop, or you're a gunsmith, or you're a general in an army, all of these things are complex environments in which you try to design, train to, and implement these kind of operating concepts prior, of course, I keep repeating myself, but I'm doing that for a reason, to developing those rational CONOPS so that everything falls into place to meet the intent of what you're trying to achieve. So sequentially, to move from OPCON's operating concepts to the formal concepts of operations that we're trying to get after, you're going to build on the responsibilities of the parties involved. You're going to add background and color to the past and present problems that you've identified. You're going to discuss those changes to be made. You're going to discuss the resulting end state. I cannot emphasize enough the importance of intent, the importance of end state, and the importance of having that as a constant thing that everybody is aware of at every stage of discussion and this enterprise. Now you're going to add operational scenarios, and you're going to follow an established format that you've all agreed to, because the military demands certain formats, commercial aviation demands certain formats. I'll bet those of you out there who are in either provisioning goods and services or creating things, you guys all have your consensus formats on communication that get you moving the ball forward. That's what this is all about. Speaking of consensus definitions, I need to bore you a little bit by reading you what the definition is from Defense Acquisition University, which is part of the joint system here in America. Now, the DAU, Defense Acquisition University glossary definition of concept of operations is a verbal or graphic statement that clearly and concisely expresses what the commander intends to accomplish and how it will be done using available resources. Now, an alternate definition, and this is provided on the website itself, which I'll put in the show notes, a verbal or graphic statement that clearly and concisely expresses what the commander intends to accomplish and how it will be done using available resources. With this addendum, the concept is designed to give an overall picture of the operation, also called Commander's Concept or CONOPS. And then they say, quote, as described in the acquisition manual, a CONOPS describes how a joint force commander, in this case a joint force commander is somebody who has two or more from the respective services, let's say Army and Air Force, or Air Force and Navy, or Army, Navy, Marines, and Air Force, may organize and employ forces in the near term, now through 7 years into the future, in order to solve a current or emerging military problem. These CONOPS provide the operational context needed to examine and validate current capabilities. Additionally, you may use the CONOPS to examine new and or proposed capabilities required to solve a current or emerging problem. End of quote. As I've told you before, I spent almost 2 years in Afghanistan, and for the life of me, I searched for rational and effective CONOPS at the operational strategic level, even general grand strategic level. I found nothing that would satisfy what was really needed to have an effective or rational CONOPS. Now, I rarely credit NATO with being either successful or effective, but nonetheless, the Eurocontrol definition of a CONOPS is interesting to me. Quote, a CONOPS is a detailed description of how an operational concept is applied, as we've just discussed over the past 15 minutes. It identifies the functions and processes and their corresponding interactions and information flows, concerned actors, their roles and responsibilities. So I think that captures almost the essence of it, but nonetheless I find that it has some shortcomings. NATO will tell you, thanks to DTIC, a clear and concise statement of the line of action chosen by a commander in order to accomplish his mission. So I want to examine this a little more, and let's do some linguistic archaeology here if we can. So I'm going to NASA, which stands for Never Ascend to Space Again, but when it comes to systems engineering, they have some of the best documentation that I've ever seen. And in one of their publications, From 2017 at the 27th Annual INCOSE International Symposium, which is the Systems Engineering Professional Organization, they said something really interesting here, and that was that what is a concept of operations? Quote, the first recorded use of a CONOPS document was in the paper by R.J. Lano, A Structured Approach for Operational Concept Formulation, and it was from a structured systems group in 1980. With over 36 years, remember this is 2017, of CONOPS history under our collective belts, it would only be logical to conclude that the term CONOPS has a very universally accepted meaning. However, if you ask systems engineer today for a definition of the CONOPS, you will get a wide variety of responses, with each individual answer heavily slanted toward the type of work or systems with which each particular systems engineer is working. Sometimes a single diagram will be referred to as a CONOPS, and other times a rather lengthy and detailed document. NASA's Lifecycle Processes and Systems Engineering course describes an operations concept as having a variety of common names at each level. At the system level, it's a CONOPS. At the configuration level, it's a user's manual. At the component level, it's a design description. Now, there are many official definitions of a concept of operations. So that paper will start by acknowledging these definitions and will then establish a working definition for a specific CONOPS that is being tailored for the Launch Services Program. Now, of course, this is very NASA-centric. But nonetheless, it tells you that despite the fact that concept of operations seems intuitively as a pretty simple concept, even though it's tedious, laborious, and demands a lot of detailed work and thinking, nonetheless, there are still schisms within the industry and within the government on exactly what they're trying to deliver when they do CONOPS. ITTT tells us that they describe the functions and characteristics of the computer system within the overall system, that the CONOPS represent a consensus among development, support, and user organizations on the operational concept of the system being developed. Notice they're employing that term, operational concept, which is the preamble to concepts of operations themselves. And by the way, listeners, I apologize if this seems so pedantic and arcane and such, but it's a very complex subject to try to get across, and I'm trying to do it as simply as possible. There are three groups of CONOPS definitions. You'll have commander's intent. You'll have the user's plan, which tends to be IEEE and NASA-centric. And then you'll have systems engineering documents, which are like what the professional systems engineering umbrella organization of INCOSE puts forward. Now, solid thinking concepts, from which I got a lot of these ideas, and kudos to them. They tried to take the hybridized three systems that I talked about just now, and they came up with their own definition, which I stand by. A CONOPS is a formal document that employs user terminology in a specific prescribed format to describe the rationale, uses, operating concept, capabilities, and benefits of a system. And let's keep in mind, CONOPS only apply to systems. And STC, solid thinking, they call systems, quote, an arrangement of items, components, peoples, or organizations that are interrelated and which interact in some way with humans or human surrogates in the loop to form a larger or greater entity or to accomplish a larger task. So that ends part one of this particular episode and what appears to be evolving into a series. I'm stopping at this point in case I have listeners who are driving, and if I have made use, I'm ambulant. I don't want you to have an accident. But nonetheless, and this is rather complex to do in an audio environment where you don't have visual or video aids, because I'm not doing this on YouTube or I haven't employed cameras in the podcast or anything like that. But nonetheless, in the show notes, I will provide you with some documentation that you can review if you want to get a more detailed and nuanced overview of what we've discussed today. So this is Bill. If you want to get in touch with me, you can write me at cgpodcast@pm.me. That is cgpodcast@pm.me. I invite you to visit my Substack, where you can leave comments. I invite you to look at the blog and where some of, well, actually all of my podcast episodes are, at the Libertarian Institute, where I am a fellow. So with that, I always appreciate your solicitude and listenership. This is Bill, out.